Probability basics. The probability space consists of three elements: the set omega, the algebra of its subsets A, and some non-negative function P defined on the algebra of the subsets. It satisfies the standard properties. Probability of the whole space is 1. Probability of the disjoint union of the subsets is the sum of the probability of the subsets, and probability of the empty set is 0. The first example. Discrete probability space consists, for example, of 3 elements, 1, 2, 3, and the probability is defined on all its subsets. On the basic elements, the probability is equal to 1 over 3. The question to you: what is the probability of this event? Union of two elements, 1 and 3. Second example, continuous probability space. This is, for example, interval from -2 to 1. The probability is defined on all its measurable subsets. On the intervals, it is integral from a to b of x squared dx multiplied by some constant. The elementary subsets, the intervals, generate all the algebra. The question: why is it probability? Why all of these conditions are satisfied? And the second question: how can we find the constant c? Which of these conditions should we use to determine the constant c? This is the question to you. Exercise 0.1. Random variables. Often we will omit the algebra of the subsets, assuming that it is visible from the context what is the algebra of the subsets. For a probability space omega p, the random variable is some function from omega to real numbers. By definition, the probability of the event xi belongs to some set A of numbers is the probability of pre-image of this set A. The first example. The probability space, again interval from 0 to 2 with the standard uniform measure. Probability of the interval AB is B minus A divided by 2. We need this factor divided by 2 because the total probability should be equal to 1. So this is just a length of the interval divided by 2. The random variable is xi is equal to x power 2. What is the probability of the event xi less than 1 over 4? We have probability of this event is equal to probability of the set x power 2 less than 1 over 4, because xi is exactly x squared. We just substitute instead of xi, x squared. Taking the squared root of both sides, we obtain that this is a probability of x belongs to interval from -1 over 2 to 1 over 2. As this probability is equal to the probability of the interval from 0 to 1 over 2, because negative part of this interval does not belong to our probability space. So this probability of the negative part is equal to 0. So that's why we have only 1 half of this interval. And this probability, by definition, is equal 1 over 4. The question to you: what is the probability of this event, xi greater than 1? Random variables, expectation, mean, and variance. The expectation is just the average of the random variable over the probabilistic space with this probabilistic measure. This is a functional, this is just a number, this is linear functional because integral is linear, and using the definition of expectation, we can define the variance. Variance is the expectation of xi minus expectation of xi power 2. Opening the brackets, we obtain this identity again using the linearity of the expectation. If probability p is generated by some density p of x, it is just an integral. The probability of intervals is just integral from a to b of p of x dx with some non-negative function, then expectation can be computed as the integral p of x multiplied by zeta of x dx. So in the simple case of the probability defined on the real numbers with some density, the expectation can be computed by using this formula. The first example 2.0. We have discrete space consisting of three elements, 1, 2, and 3, with the uniform probability P of elementary subsets is equal to 1 over 3. And the random variable is xi is just x power 2. The question, what is the expectation of this random variable? We use this formula. Expectation is average over the probabilistic space. So we need to take, we have x squared, so we have at the point 1 x squared become 1 squared, at the point 2 it becomes 2 squared, at the point 3 it becomes 3 squared, and we need to multiply by the probability of these numbers 1, 2, and 3. So taking this, computing this sum, we obtain 14 over 3 by definition. Variance can be computed in the same way. This is expectation of xi squared minus expectation of xi power 2. Again, expectation of xi squared, this is sum of this form, but here we need to take xi power 2. Xi is already x power 2, so in power 2 it becomes x power 4. That's why instead of 1 squared, 2 squared, and 3 squared, we need to substitute 1 power 4, 2 power 4, and 3 power 4. And after computing this sum, expectation of xi squared, we need to subtract expectation of xi power 2. So 40 already computed, and we obtain this value. This is second example. The question 2u. What is expectation of xi and variance of xi in example 1.0? You remember? In the example 1.0, the probability space is continuous and random variable is the same, x power 2 as in the discrete space, x power 2, but the space is continuous. Try to solve this exercise.